In today's video, we are going to understand the concept of M-ary PSK. Basically, M-ary signaling scheme can be of two types. One is M-ary PSK and one is M-ary FSK. M-ary PSK is M-ary phase shift keying, M-ary FSK is M-ary frequency shift keying. In both the methods, one of the M possible symbols is transmitted during each interval, during each signaling interval. For example, M can be any number. If you have suppose 3 bits combination, so you can generate 2 raised to the power 3, that is 8 different combinations, that is from 000 to 111. So 8 different symbols can be transmitted, that will be termed as 8-ary PSK. If suppose you are combining 4 bits, then 2 raised to the power 4, that is 16 various combinations of bits are possible. So that will become a 16-ary PSK. So in general form, we can say that it is a M-ary PSK technique. There is a comparison chart, like type is BPSK, that is binary phase shift keying, in which our bit duration of every bit is TB seconds. And how many symbols are there? 2 symbols. One symbol is 0, another symbol is 1. And phase shift of that particular BPSK is 2 pi by 2, that is 180 degree. We have already seen the phase shift keying in which both the symbols are transmitted with 180 degree phase shift. Similarly, we have also seen the QPSK, in which the bit duration is 2 TB second, because we are combining 2 bits and producing the 4 different combinations, that is 00, 01, 10 and 11. So all the 4 symbols, that is number of symbols will be 4, will be having phase shift of 2 pi by 4, that is 90 degree. So between 2 symbols there is a phase shift of 90 degree. Same way M-ary PSK, that means we are generating how many symbols? M symbols, and the bit duration will be NTB, where n is any integer. Then phase shift will be 2 pi by m. So this is how you can compare various types of phase shift keying techniques. Now we will see the M-ary PSK transmitter. So in M-ary PSK transmitter, the bit sequence which we are going to transmit is this, and then this bit sequence is converted from serial to parallel. Now serial to parallel conversion will be something like this. There is a bit stream coming. If you are combining 3 bits, so that means how many combinations are possible? 8 combinations are possible. So that means either 000 or 001 or 010 or 111. Such 8 combinations will be possible. If you are combining the bit sequence in 2 bits each, then there will be only 4 different combinations possible. So accordingly, we can create various M-ary technique. Then this D2A converter will convert this digital data into its corresponding analog signal. Like 000 will be converted into its corresponding analog, 001 will be corresponding analog signal will be there. And then corresponding to this VA, a sine wave will be generated, which is nothing but a phase controlled sine wave. This phase controlled is on the basis of this VA. Obviously the value of VA will be different for all the different combinations. If suppose you are considering QPSK, then there are 4 different signals, 00, 01, 10 and 11. 4 different signals will generate 4 different VAs, and if 4 different VAs are there, then their phase shift will be 4 different phase shift according to the value of VA. So that means 4 different symbols or 4 different signals are generated. That will be known as M-ary PSK. In this case 4-ary PSK. Accordingly, if you are combining 3 bits, that means 8 different signals will be generated. All the 8 signals corresponds to a different VA, and then that VA will be transmitted with the help of different phase, which is controlled on the basis of the value of VA. So that output is nothing but the M-ary PSK signal. This is how M-ary PSK transmitter works. Now we will see the M-ary PSK receiver. The M-ary PSK receiver is almost same as BPSK as well as QPSK. In both the techniques, we have what we have done, we have generated the carrier from the carrier recovery circuit. You must have remembered that in the binary phase shift keying we have used here square law device. Then in QPSK we have used raised to fourth power because 4 different symbols were there. Now here we have m different symbols, so it will be raised to mth power. Then this will be passed through a band pass filter which is blocking the m omega c frequency, and then it is given to the frequency divider divided by m. Same way in QPSK, here we were using 4 omega c and we were dividing the frequency by 4. So this way we are generating the cos omega ct and sin omega ct, both the carrier signals, from this blocks which is known as carrier recovery circuit. This is actually understood to you because we have already seen this in BPSK as well as QPSK videos. So the cos omega ct and sin omega ct signals will be generated and given to the multiplier, and the second input of the multiplier is fed with the M-ary PSK signal. So when M-ary PSK signal is multiplied with cos omega t and sin omega ct, you will be getting 2 different signals, and then it is given to this integrator circuit which works as a low pass filter. This low pass filter will remove the high frequency component and gives you the various different frequencies. Obviously if we have 8 different signals, then 4 signals will come from here, 4 signals will come from here, even signals will come from here, and odd signals will come from here. That means 4 with cos omega c frequency and 4 with sin omega c frequency, because you are transmitting the signal with 90-degree phase shift. So first 90-degree phase shift will be cos signal will become sin, and then again 90-degree phase shift, that signal will again become cos. So you will get 4 cos signals and 4 sin signals. So out of 8, 4 signals will come from here and 4 signals will come from here. And then there is A to D reconversion. Again we are converting this analog signal into its corresponding digital signal. That means what you will get? 000, 001, 010 till 111. So various 8 signals will be there from this output, and then this parallel to serial converter is given to this. The output will be nothing but the bit sequence which we have transmitted. So this is how your M-ary PSK receiver works. As far as the mathematical expression for M-ary PSK is concerned, it is represented by A cos omega ct plus phi I, where I is equals to 0, 1, 2, 3 till m minus 1. And then this phi I, which is the phase angle, is nothing but phi I is equal to 2i plus 1 into pi by m. This is how you can generate various M-ary PSK signal. So basically this is all about M-ary PSK signal. The advantage of M-ary PSK is when you want to conserve the bandwidth, M-ary PSK signal is used. But to conserve the bandwidth, we have to face some disadvantages, like the power consumption will be more and the error probability will also be increased. Obviously when the number of symbols increases, the error probability increases.